Hi Harsha, are you able to hear me? All right, I'm also doing great, Harsha. Thank you. And hello, Mehdi, can you hear me? Hi, good morning. For you, it's good evening, Mehdi. Great. So, all right, before we start our next session, do you have any questions for me? I'm just trying to figure out till what point we had discussed in the last class. All right, great. Hi, Gaurav. Did you have any questions on Python? All right, again, all of you. All right, so a quick recap. Which of the following functions are okay for reduce? If you remember our discussion last time. So this is like a native usual function oriented programming as in functional programmings. And we were discussing about reduce last time. Okay? So the idea of executing reduce over an array, was it clear to you? So if you remember, we discussed this part in the last session where we defined a small function called mysum, which takes two arguments and returns summation of the two values. Now, instead of we ourselves executing this function on an array 2 at a time, we are asking a function called reduce to do that. And how would reduce do it? We'll first execute it on two numbers, then another two numbers, and then on the result of it. So it'll be like this. Okay. So it'll get executed, and the result will be 10. So it got executed on 1 and 2 first, and then 3 and 4 in parallel. So here there are a few important things to note, that this thing can work in parallel. So it could also happen that on one machine the summation is happening, and on another this is happening. That is why this reduce function makes lot of sense for distributed computing. Earlier at the functional time, this is something which was not thought about. So reduce function was actually coined at the time where there was no plan of distributed computing, but but it turned out to be a greatly useful function. All right. Okay. So question to all of you, based on what we have learned, that which of the functions are okay for being a reduce function? Yes, Ashish, Gaurav, Harsha, Mehdi. All right. Good morning, Ashish. So Ashish, do you, all right. Before you ask further questions, do you need a recap of what we have discussed? Or is everybody comfortable with the idea of reduce function? All right, it looks like everybody's comfortable. So question is that out of these functions like average, min, max, and then square root of sum of the two squares. Okay. All right, let me go back again. Let's take a case of average, all right, and go back here. Let's say, suppose we had to compute average of two values, 1 and 2. Okay. So what we're doing is instead of computing the average just like that, okay, we are using reduce function. The objective of a reduce function is to to basically take two values at a time and return one, and keep doing it unless all the values are exhausted. So this tree shows you the same idea. Let's say we had to compute the average of these two values. So the average of 1 and 2 is 1.5. Okay, let me replicate this slide and then it will make sense. Okay, and help me fill this. Okay, help me fill this. So this is all right. Now, all right. So this will be how much? Yeah, this will be 1.5, correct? So 1.1 and 2's average is 1.5, and similarly, we computed the average of 3 and 4, which is 3.5, right? Now the average of 3.5 and 1.5 is 2.5. Okay, now this sounds good. This sounds good that okay, we had been able to compute. Now let's do a little different thing. Let's try to switch their places and see whether it still makes sense or not. Okay, so the average of 4 and 1 is, all right, let me just do some more different things. Okay, so the average of 3 and 1 is how much? 2. Okay, and 4 and 2 is, all right, okay, okay. So let me just keep only three values, or let's have one more value. Let's say 11. Okay, so let's say we have to compute the average of these values. There are 11 values, there are 5 values. Okay, and say this is 12, and and okay, and once finally then we have this, we will compute one more box. Okay, so we basically are trying to say that we'll take two values at a time and compute the average. So the average of 1 and 3 is 2, 4 and 12 is 8, right? And the average of 8 and 2 is 5, and then we have average of 5 and 11 is 8. Is it correct? So I changed the problem statement a bit. So we have to now compute the average of these many values. All right. So 31 divided by 5 is how much? If you compute if you compute 31 divided by 5, okay. So ideally the average could have been, okay, 31 divided by 5, which is how much? Okay, but when we computed using reduced method, the answer would be 8. Does it make sense to you? No? You want to compute it? You want to see if it is really what I'm saying that's correct or not? Let's start Python. And let's say I define an array 1, comma 3, comma 4, comma 12, comma 11, and I define a function uh, and which takes two values, okay, and return uh, x plus y divided by 2.0. Note the 2.0 because that is important in in making sure that the division is decimal as we discussed last time. Okay, so you can see that it's working for two values. Now let's try to make it work for uh, for a range of values. Okay, so using the reduce function. Okay, so you can see that the answer is 9, but if you say sum of a divided by length of a, the answer would be, okay, and how do I convert it? I think this will do. Yeah. So if you see, if I sum all the values of a using the normal sum function and divide it by the length, then it is 6.2. While if I pass the average function to to the reduce method, the answer is 9.5. Okay, because it might be doing from this side. Okay, if you do it from this side, the answer might be different. Okay, so did it make sense? No. So Ashish, is it clear or should I recap still? Yeah. So what did we understand from this discussion? We understood from this discussion that reduce function is not good for all kinds of computations. Because in case of reduced function, same function here, the way we are applying the average function again and again on the result. So actual values also we run the same function as well as on the result of those, mm, in the first pass, the same thing will be applied again. And there is no guarantee in what order it would be applied. There could be a scenario where this 4 will be combined with 5, and then you will have the another function like something of this sort. Okay, something of this sort you will see and say like this. Okay, there could be multiple say permutations. Okay, something of this sort. So in that case you can see that 4 and say, all right, so 2 and 4 it'll be 3, and 11 and 12 it'll be how much? 11.5. Okay, and 11.5 and 3 is 7.25. Okay, now you can see that the values are differing every time we change the combination, right? And they are different from the original. Okay, let me show you the script once, the one which we did just now. All right, so here is the script. Okay, so let me try to copy it. And I'm just sending it to all. Okay, so you can see this section. All right, sounds good to you? Gaurav, are you comfortable? Ashish, Harsha, Mehdi? All right. Ishwar, are you comfortable? All right, great. And Jitender, are you comfortable with the reduce function, what we've just discussed? Great, great. Now coming back to the question, so which, based on our discussion of how do we compute reduce, how does the reduce work? Do you think average, min, max, and the last function, they are suitable for reduce function? Or which one of them are okay for reduce function? So you have to reply to me in terms of one, 2, 3, 4. Okay. Which of the following functions are okay for reduce function? Okay. So Gaurav says 4. It can be multiple, Gaurav. Ishwar says 2, 3 are okay. Harsha says 2, 3. Okay. Not the fourth one? All right. Let's check it out. Okay. So we had, what do we have? A. A is an array of elements. Okay. Let's try to square it. And how do we square? Let's try to use some function like map, okay, which takes, let's say, square x, and then all it does is return x into x. So we are squaring all of the values. So first we are trying to do it without reduce, okay? We are trying to square all the values, then we'll sum it up, and then we'll do the square root, okay? Now let's do the square. We say map, and we say square, and we say array. Okay, so you can see that. Let's assign it to the new value. Okay, we'll call it s. Now s has got the square values. Now let's do a summation of this array. Okay, which is this much, and divide it, and then we'll say sqrt, and yeah. So we can say math.sqrt, but we have to import math before that. Okay. So you can see that the answer of square root of summation of values is 17. Okay. Again, what we did was we took an array, squared all its values. Instead of using a loop, we are using a map function which has imposed our function we on each and every value. So this function what we see just now here is square. It has basically been applied on all the values, and then we have done the summation of all the values, which is coming out to be 291, and the square root of 291 is 17. All right, so let's just keep it in a notes that, okay, let's just keep it in a notes. So the answer is 17. And let's try to do a reduce. Okay, is everyone with me? Good. All right, let's try to do a do using reduce. Let's define our function, define my function, which takes two values at a time, okay, and returns math dot sqrt of x into x plus y into y. Okay, okay, let me just see what did we do wrong. Return. Oh, I wrote returns. Okay. And then we say x into x plus y into y. Okay, good. Let's just test our function if it is working or not. So we are executing my f with 3 and 4. So 3 and 4, 5, perfect, fine. And 3 and 3 is square root of 18, which is 4.2. So which means the function is fine. All right. Now let's try to do a reduce. So our array is this. Okay. Our array is this. That's what we did just now, right? Our array is this, and let's do reduce name of our function and then the name of the array. The answer is 17.05. Okay. Do you see that? How did it happen? So as per our example, what we've just done, it's the approach is perfectly fine. Or if you want, let me just make a note of it, and let me just extract it, and probably that will make more sense to you. Okay. So yeah. So there was one approach which we took earlier, and this is our second approach. Do you see that? And yeah. Now, let's go back to our previous approach. What we did that time was we defined a function. All right. We defined a function. We took an array. We squared an array using map function. We could have simply iterated as well, gone through one value to another, but idea was to give you a feeling that what happens. Okay. So, okay, we stored it in as, and then we summed up the values of as, and we combined all of this together. Yeah. Okay. Let me increase the font. Okay. So, are you comfortable with this, or should I? I know you're not comfortable, so feel free to ask. So in the first approach, we basically tried to square all the values. So we squared using a map function. And if we forgot, what does it mean by map function? Your map function makes your function run on every element of an array. Okay, these are the function not from the Spark, but these functions are from Python. This is in the basic library of Python, and they are part of the functional programming language. Not only Python, but other functional programming language such as Haskell and Scala. All of these functions are part of the basic library. Okay, and after that we just imported math library and computed the square root. So that was our approach number one, and this is our approach number two. Yeah, Gaurav, Ashish, Ishwar, Gaurav, Harsha, Jitendra, Mahedi. Is it clear to you? So what we saw was the function like this, which takes the square of the values and sum them up and compute the square root, is a valid reduce function. So Gaurav is saying we can use reduce where order of elements are not important. Correct. Where first order is not important. Second, applying the same function on the output of the previous executions, it should give the correct results. Let's take the case of this function. So here, let's say we are trying to compute this, right? And let's say we had x, y, and z. Let's just talk about in algebraic terms x, y, and z. Okay, so when function will be applied on x and y, the result is x1. X1 equals to function of x comma y, which is the square root of x square plus y square, right? That's our x1. Now, when x1 and z are combined together, the overall result will be function applied on x1 and z, and the result is square root of x1 into x1 plus z into z. Okay, now if we go further, what would happen is that will become square root of what is x1 square? X1 square is this one, right? X1 square is this, right? Because if you square it, x1 square will the x1 is equal to square root of this one, so x1 square will be without this square root, right? So x1 square will be equal to x square plus y square, and therefore the result will be like this. Okay, so square is basically cancelling the square root, and that's how it's happening. Good. Let me just save the notes. Great. So all right, now what is your all of you, what is your final answer now for this question? Answer, give you can there are multiple choice, this is multiple choice question. Out of 1 2 3 4, which all are okay for reduce? All right, Gaurav says 2 3 and 4. All right, Okay, good. Ishwar says 2, 3, and 4. Harsha, Mehndi. Harsha says 2, 3, and 4. Mehndi says 4. So, okay, Mehndi, do you think min and max are not okay for a reduced function? Do you want a little walkthrough? Let's take the same case, okay? Let's take the same case and we'll just apply the function again and again on the outcome of the values, okay? Let's try to do for min. Let's try to do for min. So help me out, okay? So the first box goes with the min of the two values, 1 and 3. 1, right? So basically, we are applying whatever function is given to reduce, it will recursively apply. As in, it'll first apply on the actual values, then it will keep on applying on the result of the actual values. And there could be a case where actual value and the result of previous values might be combined together to produce a new value. Okay, so all of these functions like min, max, sum, or any of the reduce function takes two values and return only a single value. Okay, so between 4 and 1, 4 and 1, what is the minimum? 1, right? Between 12 and 11, what is the value? The minimum one, which 11. Out of 1 and 11, it is only 1. So if you see, no matter in what order you apply the function, whether you take these two values or any values, your 1 will always end up as minimum. Okay? No matter in what order do you apply. Same is true for max. No matter what you apply as a max, it will always end up the same. Okay. So let's say if we have to apply for max, this will become 3, and 3 and 4, the max will be 4, and out of 12 and 11, the max will be 12, and out of 12 and 4, the max will be 12. So effectively, in case we are applying max function, we'll get the correct result again. All right. Now let's go back to, so Gaurav's question is answer is correct, Ishwar's answer is correct, and Harsha's answer is correct. And Ashish, now uh, we discussed about how square root, sum of square root is also square root of sum of squares is also a valid function in this. Okay, so therefore it's a valid. Out of this, the answer is 2, 3, and 4. Everybody got it? Yeah? Everybody okay with this answer? Jitender, Mehndi, Mehdi, are you okay with this? All right, all right. Okay, so let's move on. We'll have more and more question. Again, we discussed in the last session three things: filter, map, and reduce. Okay, so what did filter do? So you have to match these answers. Can you match these answers? Yeah. Okay. So Gaurav says, all right. For everyone, the question is that you have to match the function with the output. So when we apply map, do the values remain become single, or do the value number of values remain number of values in the output of reduce map remain the same as number of values in the input? So when we applied map here, if you see just now, we applied map on our array, and the result was this much, square of all the values. So the output is having single value or as many values as in the input, or less than or equal to the values in the input. Ishwar says second B, okay, and one C, okay, and third A. That's correct. Okay, so Gaurav, your first answers were correct, and Ishwar's answers are also correct. Good. So yeah, so the answer is like this. All right, everybody okay with this? Great. Any questions at this point? Now, question to all of you is, we discussed about map, reduce, and filter. What is filter? It takes a function from you and an input array from you, and it applies this function on every element of the array. If the result of the function says true, that value from the array goes to the output. In case in case the function says for a particular value false, then that value does not go to the output. Basically, filter filters the data from one array to another. Okay? If you are looking for only certain class of values out of an array, you can use filter. Comfortable? So how are map, reduce and filter distributable paradigms? Anyone? Do you feel that can they be distributed? Can they help us executing our code in distributed fashion? Can they run in parallel? Can they run on multiple machines? Can we carry our code to multiple machines in parallel? So if we have got a very big array, can we execute our map function in parallel on multiple machine? The answer is yes. By philosophy, map, reduce, and filter takes the data, apply the function on data, meaning they are making the code move rather than your code reading one value at a time from a big array, looping over it and saving the value, right? There's a traditional paradigm. Instead of the traditional paradigm where we take one value at a time from the input, apply something on it, or maybe more values at a time from the input, apply some function on that input and save the data back. That's a traditional way of doing it. But if you have to distribute the computing, you should be able to parallelly process values and save it and reach the result. Okay. So that's why all these three paradigms, and you will see more such paradigms which distribute your logic, which make it possible to involve many computers to solve a simple problem like square root. Okay, so if you have a millions of values which need to be computed, of which square root need to be computed, nothing to worry. You could use one of the available frameworks and use map kind of a paradigm to compute the square root. All right. As we go ahead, we will see more about lambda function. Okay. So every time we had to run our reduce function, we had to write define we have to define the function first and then do the map, right? Which is very counterintuitive. You will start writing the map and then you'll realize, oh, we have to define a function first and then come back. So so lambda function is more like a inline function inline function. Instead of defining it up front, we can use it once and just ignore it. Okay. So for example, this is our usual function. We are defining the square. We are saying x to the power 2 and then it's returning us 64. In case of lambda, we could just simply say like this. Okay? We could say simply g equals to lambda x into this and then we'll have this. Okay? Now, we can use lambda-like function very quickly to give the results. You can see that we are applying filter. Filter says if x is divisible by 0, then only keep the output. So it returns this value. It's a single expression. You see that? It's a single expression which says return return x divided by 3 equals to x remainder 3 equals to 0, meaning if x is divisible by 3, it will return true. If x is not divisible by 3, then it will return false. So if you do x divide by 3 as in percentage 3, meaning it's a modulo, meaning the the remainder will be 2. If you divide 2 by 3, so 2 will be the remainder, and 2 equals to 0, that means it's false. So filter will not put that value in the output. If you say 18 divided by 3, it'll be 0. There'll be no remainder, and therefore 0 equals to 0 means it is true, and therefore 18 will be put in the output. If we go further and do for 9, so 9 modulo 3 means 0. There'll be no remainder if you divide 9 by 3, and therefore it will again return true. This function, lambda function, will be returning true. Okay, so basically lambda is nothing but an inline function. It's not a big deal. If you don't get the lambda function, don't use it. I personally don't use lambda function because I'm not very comfortable with it. Okay, I don't use inline function in Java generally. So, but it's quite useful when you just have to do very small things like doing a square or doing something like that. Okay, let's say if we had this array and we had to quickly filter. Okay, we could do filter, or we define our function up front. Okay, or we could say lambda x, and we could say x, let's say percentage 2 or percentage 3 equals to 0 on a. So you can see that. Or we could say simply x equals to x equals to 1. Okay, now you can see only 1 has gone into output. Right. Similarly, if we have a and we want to square it. Okay, we could say lambda x into x, and that's it. You can see that we could square the values very quickly together. Okay, this is inline function. Any questions at this point? Those functions which have very small definition, they are good fit for lambda. If their function is having big definition, if your function is big and complex, don't make it a lambda. All right, a quick assignment to all of you. So you have to did anybody write the pay computation part? It's a very simple program, probably the simplest one, in which you have to pay, I mean, compute the hourly rate. Okay. All right. Or you could have simply used the the general aspects. All right, so we are almost done with Python. Any questions? We'll not go into more object-oriented programming in Python because that's not very much required as of now. Only the functional aspects we are going to touch. We have touched so far. Any questions at this point? No questions? Okay, so for Gaurav, lambda is not much clear. All right, so I'll just describe it again. All right, so here lambda is essentially an inline. Let me try to explain again. Let's say we have this nice problem. Okay, what we have to do is out of out of this array, we want to find out all the values which are divisible by 3. Okay. One is that we say for x, we create an array, new array equals empty array, and then we say for x in foo, for x in foo, new if x percentage 3 equals to 0, and put it in new array dot append x. Okay, so this is one way of dealing with it. Okay, let's try to do if we can. Okay, now we could say for x in foo, do this. Okay, so now you can see new array. All right, till here you're comfortable. All right, now let's try a different approach. Now let's try to do a filter kind of approach. This is iterative approach. What we just did was iterative approach. Okay, we went through item by item, checked it against a condition, and then if that condition is valid, it's okay. Now this kind of approach, iterative approach, sounds great, but this kind of loop cannot be divided into multiple computers or multiple processors. Okay, now second approach could be that we define a function called is divisible by 3. Okay, now this function will return true. Okay, if x percentage 3 equals to 0, return true. Or we could easily say this kind of thing as well. We could simply say return this value. So return this, something of this sort. Okay. Okay, so let's try to do that. So let's test our function whether it's created correctly or not. So is divisible by 3. This is good. This is good and good. So basically the function is working fine. It's returning false if the number is not divisible by 3. Now we could use a function like filter, which is provided by Python, which takes your function like this one and applies on an array, and only those arrays, only those elements of the array that qualify this function will be put in the output. Okay, so now you can see that it has given us the result. All right, now moving ahead. Okay, so in this approach we had to define the function earlier, right? Even though it's just single line of statement, still we had to define it. So in case of defining it, what we could have alternatively done is, instead of going back and trying to create a function, we could have just embedded our function here itself. It has no name. So the keyword here is lambda. Lambda x, as in x is the argument to the lambda. So uh, this gets replaced by basically, uh, I'll show you how does it. So when we create it into anonymous function, this gets replaced by lambda, and the brackets are not required, and then return is not required, and this is what becomes our lambda function. Okay, like this. So whatever is the result of the whole expression, that will is the return value of this lambda function. Okay. Now you saw that it actually worked fine. So it's basically an anonymous function which cannot be referred by other filters. Okay. This is very internal to it. Other functions cannot access it. So Gaurav, lambda is clear to you now? Great. Anybody else has questions for about lambda function? Lambda function is nothing but inline anonymous function, okay, which has no other existence than this one. Sounds good? So Iswar, Mehdi, Jitender, Harsha, Ashish, are you okay with the lambda function? Great, great. Now there was a question from Harsha, that what level of Python do we need for Spark programming? This kind of level is good. What we are at right now, this is good enough. Okay. Basics of loops, basics of, variable declarations. Along with that, the basics of these functional programming is good enough. Although some might say that object oriented is required, in my opinion, that's not required. Okay. Even when we will discuss it in detail, that even when you are going to use Spark programming within your object oriented program, then try to avoid the large objects. Okay, so we will stick to, you don't really need too much of object oriented programming in this. Okay, so we'll not get into that details. So Madhy's question is, do you provide Python course for Spark? There is no separate course so far, but yeah, we are planning in the future. We're planning in the future a Python course for Spark. But this would be good enough. Whatever we have discussed in this session is good enough for going ahead with Python. All right. If you have doubts about Python, feel free to ask. Okay. The only reason why we have gone with Python is that is the most simplest language out of Scala and Java. Also, it will give us the results immediately, and we don't need too much of efforts. Okay. In real life also, Python is very well used with Spark, and lots of people are already comfortable with it. All right. Now moving ahead. Any other questions at this point? All right. I'm assuming there are no more questions. Good. Good. So please finish these exercises and it'll be good. Okay. Basically, you have to just compute a multiplier and that's it. Okay. Try to write a simple program like computing the taxation. I mean, compute the tax. That's all. All right. All right, moving on to the fourth session, which was planned for today. All right, so welcome back to Spark. We were discussing Python in detail, and whatever we have discussed. All right, good, good. Thank you, Ashish, for that question. His question is, what is the command to list down user and system functions? Great, thank you. And what you can do is basically on every object, say array is there, we could say dir a, and you see without underscore. Okay, those are the functions, or you could say help a. So these are the methods which are available as part of this object. So add means plus operation, and contains means in operation, and delete means delete operation on an array, and so on. So you can see that all of the functions that are available as part of array are here. So let's try to see if you have an array like this, 1, 2, and you have b 3, you could do a plus b. Okay, or you could say, and let's go back to help. So we tried this, and we could also do things like y in x. So we have got a, we can say 2 in a, it says true, and if we say 20 in a, it will say false. Okay, now let's go back to the manual. So there is delete item. If we have to delete item, we can say del a 0. Okay, now zeroth element is removed. Okay, similarly, let's go back and try other. Now delete slice, we could delete, let's say there is array 1, 2, 2, 3, 4, 5. Okay, let's say we want to delete slice. Okay, let me just see what was that. Help a, it says, okay, delete slice means delete a, and say 0 to 2. Okay, so first two elements have disappeared. You can do more. Okay, so we could also do things like equals, as we just saw, 1 comma 2. Okay, all right, so this way you can basically have a look at all the functions. If you just want to have a look at all the functions of a particular object, you can say things like this. So this will give you answers to everything. We will see this, we'll use this in the context of Spark as well. Sounds good? Ashish, were they able to answer your question? All right. So anytime you feel confused that what are the functions, just try help or dir. Okay. All right. So we will get into the Spark concepts. We have already discussed the architecture. How is it? How it can be executed in two ways. One was using the on the cluster and other was on only a single node. And the reason why you would run on single node is to utilize the core, multiple core of your machines. And on the distributed, as in on a particular yarn or mesos, if you want to run it, you want to basically exploit multiple computers to do your work. And further, under yarn there were two methods, one in which driver was run on the machine from where you are launching. In other, the driver was being run on any other node in the network, and driver was also being executed through yarn. Okay, so you can say that, going back to what we had already talked about. So if you are coming from, I vaguely remember some of you have a Cloudera license. Who all have Cloudera certificate, not license? I vaguely remember somebody was telling me from this session that they have Cloudera certificate. Harsha is Cloudera certified. Okay, all right. There were more people in this session. I think Hiren is also Cloudera certified. All right. Okay, so when you have gone, if you have time to go through our previous discussion, I'll just like to explain to you in terms of Hadoop. It's not required, but yeah, let me just explain for those who are coming from Hadoop background. So when we execute things Uzi, when we execute things through Uzi, then the Hadoop jar command, okay, we used to have this Hadoop jar command, okay, gets executed, gets executed on any node, okay. But without Uzi, if you try to execute, it gets executed on local node, okay, meaning on the same node from where you are we are you are launching things. All right. Similarly, similarly, in the same manner, there are two modes. One is client mode, where the driver application, as in your code, which runs runs on local machine. Other is in the way that in the cluster mode, as in your launcher itself, the code that launches, map, and reduces, that also runs inside the cluster. Okay, not locally. Okay, that was the brief discussion we had last time. All right. Now you can simply log in to right now you can simply log in to our Hadoop 3. Let's just log in and also say Spark 1, copy the password, copy the password and go to where is the console login? This is the console login. Okay, let's log in into console, Spark 1 and control V. Okay, so this is where it is, and I have created this folder. You see Spark here, and there is a symbolic link, so you can actually say cd Spark and you will be inside Spark. Okay, and to launch the command line, you could say PySpark, and there you are. Okay, so our Python Spark command prompt is up. All right. From here, this is basically nothing but the Python command line. All right. Let me also take it out. Take this terminal out. Okay. So it's nothing but it's basically your Python interactive uh, shell. Okay, where what we had been using so far, just that it has one extra variable called sc. Okay, so we can say help sc and it will show us all the functions that are available in Spark context. Okay, everybody comfortable? Yes. So here, whatever we had been doing so far, we can actually keep on doing the same thing because it's a Python console. There is not much of a difference. The banner is changed and one more variable called sc is available along with one more variable called sql context. Okay, so these two variables are made available to you, and all the libraries of Spark are also available here. Okay, good, good. So that was a quick starter on how to launch a Spark program, a Spark console. And let me discuss some more things. Okay. So basically, from this command prompt, you can keep on working on whatever you want. Also, if you want to submit a Python job, you can submit. So there are two modes of working with Spark. One is an interactive shell mode. Other is a usual Hadoop way where we submit our job and it gets executed by Spark. Okay. So if you want to submit your job, you can say Spark submit and give the location of your program and it will get done. Okay. If you have to submit from Java, the first you need to create a Java project, add the library. Okay, there is only one library that comes along with the Spark distribution. So, so this is the Spark distribution here. Okay, so this is the Spark distribution under which there is a library here. You can see yarn, this one. Okay, this is the library that you would require in your Java project. Okay, so I will try to show you how to import the project. There's the easiest way of getting started. So you can download this particular project. Okay, let's just download it. It's a little bigger. It's of few MBs. Okay, it's a few MBs. Where is it located? So yeah, this is located here. We can, once you download it, you can where is, how do you open, yeah, you can simply unzip it. And once you have after downloading, once you have unzipped it, you can basically use the Eclipse to import. Okay, I'll just show you all the steps that are required. Let's just create another workspace, a fresh workspace. So what we have done so far, we have downloaded the project zip, extracted it, and now we have created a fresh workspace, which means there is nothing else, and we could simply say file, import, and general, or say Java. Where is Java? Existing project into workspace, not required. In the general, it will do. You go into the folder where you have extracted the files, the project. I went here, selected this Spark EX folder and said open and then finish. All right. Now here there is an exclamation mark. Okay, let's see what exactly is missing. Okay. So here it says, I think some libraries are not found. Let me, Java build path. Remove this library, whatever it was. Okay. Remove it from the libraries. You remove the library and add external jar and browse to the folder where you downloaded your zip, you downloaded this Spark project, and in the in here, not here, yeah, you will see under here the jar file is packaged with the folder. Okay, so now this is ready, right? So once your project is ready and there are no errors, although there are warnings are not good, but we'll just ignore the warnings. Okay, we can also remove these things. We are not getting into details of what's going on here. Okay, right now all it does is it will basically convert all the lines into one word per line. Okay, all it, and it'll just take only 4 words out of it. It will load the data from HDFS. Okay, run a flat map on it, and take 4 words out of it and then print it on the screen. Okay, now let's try to create the jar folder. And how do you do? Export, select the project, and you say export, and then we just type jar. So it's a jar, and give it a name. Give the output folder a name. Okay, we'll say downloads, and what's the name? Let's just give it word count dot spark dot jar. Okay, all right, we are done. Now once we are done with it, we can upload it to the server through command prompt. We could say scp downloads. If you have WinSCP, you can use WinSCP, or if you have any SCP, you can use that way to transfer the files. Okay, so we'll say sp.jar, and we are uploading it to Spark1 at hadoop3.nobigdata.com colon and enter. Okay, now it'll ask me for the password. I know the password from here. Okay, now the file has been copied over there. Let's go into the terminal. This is our browser based terminal, and let's go into my home folder. This is the home folder. So you can see that there was already something like this. Let me just remove this. Now you see the wcsp.jar. So that's what we want to do. Okay, we were able to successfully upload, we were able to do all of this. We downloaded the project from LMS, created a fresh workspace inside Eclipse. If you don't have Eclipse, you will have to install Eclipse. Import the project. Okay. Fix the library path, go to the project properties, and under libraries, remove the missing file, add external jar, and point to the newly added jar. And then then export. We forgot to export here. Export jar. Okay. Once you have exported, then you can copy it to the downloads from the downloads. I mean, um, wherever you have kept it. And once you have done, you can start executing your program in some way like this. Okay. But our name is different. Okay. So you have to go into Spark folder. All right. And then execute this. So now you can see that it is launching a Python Spark, sorry, Java Spark job. And here is the result. We've just wanted first four words out of that file. Okay. So it has given us the project Gutenberg. So this is how you generally run a Java program. Now you can see that it's a little bigger cycle. You first code it in somewhere, then compile it, then upload it, and then launch it. Okay. Sounds good to you? All right. So all of you can now write it in this. Let me just increase the font. Okay. Let's just increase it to 18 or maybe 14. Yeah, this is good enough. All right. So that's how you execute your job in Java. All right. Let's take a break for 10 minutes and come back after 10 minutes. All right. Thank you. Hi, I'm back. Are you guys back? Should we start now? All right. Mandy is back. Harsha is back. Gaurav is back. All right. Looks like I'm the one who is very late. All right. All right. So we were just able to quickly demo how to run our Java code. What was there inside Java code that we will discuss later on. Okay. So here, the small bit of information you might need to understand is the command line what we used. First, we were in the command folder of Spark, and inside Spark folder there is a command. There is a folder called bin. Under that there is this binary, okay, called Spark dash submit. So we give that, mm, mm, I mean, the relative path to that, and then we said minus minus class as in the entry point. So we give the name of our entry point, whatever package we have in Java, that package. Package is like a folder, okay? So package name dot dot the class name, okay? To organize lot of code, we generally create packages. The way we create folders to organize lot of files, and then after that we said dot dot as in go up one level out of this folder into our home folder, and then specified the location of the name of our uh, jar file. All right, so that's it. Is the command clear to everyone? We could also do things like we could basically put this bin folder in our path directory and could have executed spark submit from anywhere, okay? Those who are not aware, so we can do things like, let's say I'm in my home folder, I can say what is our present working directory, this one, okay? We could say export path colon dollar path, which is existing path, and then the folder name where our Spark has been saved. So right now we have aliased our big name to Spark simply, and then we could say bin. Okay, we could say export path equals to dollar path this. Now when we say echo path, you see at the end you will see Spark bin, which is not a correct idea. I think we should instead say the absolute path. Okay, we should give an absolute path, not the relative one. Okay, let's just put the absolute path. Okay, now, what does this mean? This means that our binary, the command which we are going to execute, will whatever command we type, it will first be searched in this folder, then in this folder, and then in this folder, and so on, okay, then in this folder, and lastly in this folder. Okay, you can see the last one, this folder. Okay, let's try to execute py spark. Now you notice that we are not giving any bin slash py or anything. We are just executing as if it's a system command. Okay, it's getting executed really nicely. Okay, and in Unix, if you put it in bash profile, okay, it will be it will be available to all the users. Okay, we could say things like dollar like this. Okay, Spark1 is our username. Spark is the folder that contains all our code. And next time when you log in from here, you will see PySpark will be in there. By default, it will be available. Sounds good to you? So no matter in what folder you are now, it will be available to you. So were you able to launch PySpark? Gaurav, Ashish, Ishwar, Harsha, Mehdi, were you able to run PySpark so far? All right. Jitender, Ashish. All right, great. So everybody is able to get into that command prompt, and also make sure that you try creating this project, because so far as per my understanding, the biggest inertia of most of the student has been to get started. Okay, once they get started, they are able to get lots of work done, but the biggest inertia to become hands-on is to get started. That's why I've created a fresh project so that you can just download it, import it, and get started. Okay, without having to worry about things. Good, good. All right. Now that was how you basically run a Java program. If you are interested in working with the Spark in Scala, you can simply go to the terminal again and say spark dash shell. This library, this binary is again available in the same bin folder where PySpark was available. If this doesn't work, go into that folder uh, and try executing Spark shell by saying dot slash Spark shell. Okay. So in Unix, executing a command means either you provide the absolute location of the command or you just provide the command name. And if you just provide the command name, it will look into your path folder. Okay. And then it'll get it done. Okay. So either you provide the full path of the command. Full path can be provided by relative location as well as absolute location. So either way, you provide the full path of your command, or you provide just the command name, and it will just go through all the things, all the places where path is there, and find wherever it finds it first, it'll execute. Okay. So this is a Scala prompt. Again here the Spark context would be available also, similar to that one. You see that, and you can start working on in Scala from here. All right. So this is how the Scala prompt looks like. Okay. Scala is a programming language, and right now I don't think we require it, but when we require, we will go through a very quick crash course on Scala as well. We'll just describe the syntax in Jiffy at a later point of time, maybe after one more sessions. Okay. When we get more into API, then we'll go through it. Sounds good to you? All right. Now the most important aspect of Spark. Okay. Spark has a feature called RDT. Just like just like our databases have tables and programming language like R have data frames, and every data oriented language has a representation for the data. In the same way, Spark comes with an idea called RDD. What is RDD? RDD means resilient distributed dataset. It's a dataset which is resilient distributed. And what does it mean by a dataset? A dataset is basically a collection of data. You can think of a dataset as if it's a big table. Table contains rows and table keeps on increasing vertically, not horizontally, as in rows keep adding into table, right? So you can think of data set as if it's a big database table where each row is just one big object. Or in case of MongoDB, we had collections. Okay, and in if you are coming from our background, then it'll be considered as data frame. But the most easiest one to think about it is an array. So RDD is basically a data set, and or you can think of RDD as a big array. You keep on adding elements into this array, and so you can think of RDD as if it's a big array. So everybody is clear about an idea of an array. Array is nothing but a sequential lists of elements. It has no restriction whether the values have to be distinct or whatever. Though the set, if you talk about a set is supposed to have distinct values. That kind of thing does not apply on a list. So RDD is just like a list or an array where we keep on appending elements or deleting or whatever we want to do on those elements. So that is dataset. Now, what is so special about this dataset? Why do we require a new form of dataset? The important part is resilience. So, first, it is, I think I should rearrange these boxes. Okay, I think I should just rearrange these boxes. Yeah, this is better. So, the great part about RDD is its ability to distribute. It's a data set which is distributed. Okay. So resilient distributed data set. Okay. So it's a data set. You can always think of RDD like a big array. This array is, or this list is distributed on multiple machines. Meaning some elements of this array are on one element. Some elements after that are on another, some are on another. So that is the distributed nature. And this you do not have a control over. You don't have control over this, this segregation, as in which elements are on where, right? And now if you think about it, if you have elements of your data elements spread across multiple machines, now you cannot run straight away a for loop. In that's where you would require things like map. We'll go into more details there again. Now, third property of resilience distributed dataset is the resilient. Resilient means it bounces back. It bounces back into shape. It is able to recover from the failures. In case some of the machines die, some of the machines on which this RDD or this list was being hosted, if they die, the same thing gets replicated to other machines immediately and is loaded again. So that is the beauty of resilient distributed dataset. So Spark's basic concepts around which all of the machine learning, everything revolves, it is the RDD, which means since this array, which is the most basic constructs of any programming language, since they have broken down it into distributed, as in the array spread across multiple machines, since they have done that, that is why That is why the whole algorithms, starting with simple computation to very complex computation, all of that has changed. Okay, so that this is the most groundbreaking yet very simple way of very simple construct from Spark. So all they did was they took the data frame. If you have heard about R works on data frame. R has got great set of libraries where they work on data frame. Data frame is like a big array of elements. Now the problem with people were facing problem with these languages is that when they create an array in these programming languages, what starts happening is it starts filling up the memory, and therefore a single computer becomes the bottleneck. The RAM of a single computer becomes the bottleneck, and that is why most of the work was not done using these traditional systems. Using R, we could not go beyond, we could not churn the data beyond what could fit in the memory. Okay, so and and that's where Spark guys came around, and then they said they said that we will just move the basic array into an distributed one, and we will write all the algorithms around it. Algorithm, when I say algorithms such as sorting, searching, finding unique, doing intersection, and changing values, and all of the philosophy, they changed it to to make it around RDD. Okay, so now there are few more properties of RDD. I'll go into those details. Okay, so basically, RDD is not a storage. RDD is just in memory, which can be persisted onto the disk. We will go into the persistence into disk at later point of time. Okay. Okay. So RDD is not a storage which is permanent. RDD is just a representation of the data in the memory of multiple computers. Okay, so although it can be saved to the disk, but we'll come back to that later. And so most important aspect to understand about RDD is that it's fairly resilient. It doesn't fail so badly, and it cannot fail so easily, as well as in case since it's spread across multiple computers in the memory, accessing it is very easy. The only problem with RDD is when one node is trying to access data from RDD, and that data is lying on some other computer. So there is a network call. And the idea about all of the programming which we will go into is to avoid the network call. All right. So Mehdi's question is persist is always on the disk. So there are two ways of persisting. We'll get into the detail. Persisting means into the memory and into the disk. Sometimes the results you computed, you want to keep it there in the memory so that other processes can use them. That is also called persist in Spark language, Spark terminologies, and persisting to the disk is also called persistence. Okay, so persisting to the memory is something which is new, which you will hear it for the first time. Okay, all right, now the same diagram where I'm trying to show you that this resilient distributed data set has got four machine 1, machine 2, machine 3, and machine 4. This is loaded into machine 1's memory, machine 2's memory, machine 3's memory, and machine 4 memory. When you add element to this RDD, some of these elements would go to machine 1, some of these elements would go to machine 2, and so on. Okay, and this RDD is being loaded from HDFS. We can load the data into RDD from variety of sources. From many sources, we can load the data into RDD. Also, please note that RDD is sort of read-only memory. Okay, just the way string is a read-only. Okay, have you heard about string? String is a read-only variable. Okay, in the similar fashion, the RDD is also read-only. Okay, you cannot modify an RDD. What you can do is you can transform it into another form. All right. So again, so it's basically a collection of element partitioned across the cluster, and it's an immutable distributed collection of objects, or you can say array of objects, which is split in partitions which may be on multiple machines or nodes. And this object can be from many programming languages simultaneously. It can be in the data type. So, like our array has some elements in it. The elements could be primitive, like numbers or boolean or maybe string. But the elements in your array could also be complex, such as array of customer objects, array of people objects. So in the similar way, the RDD could also have any kind of objects. RDD itself can contain the RDD can be made up of all the integers, where each individual element of an RDD is basically an integer, or it could be mix of integer and string. It could be mix of float, int, and string, or it can be of any data type. It could be of your custom data type, if that is what you want. Okay, if you are trying to process the data about your customers, you could load all the customers and as an RDD containing each object as customer. Okay, now when we talk about these objects, the first question that comes to mind is, if there are two programmers who are working on something, one program is written in Java and other is in Python, can that happen? Can the two parts of a program be in different language? The answer is yes. Okay. The way the design of Spark is that you can have any form of data from any programming language. Okay. We will see in future that how we will churn how we will churn the data prepared by R in SQL. Okay, or data prepared using SQL in our Python program or Java program, and that has become a norm. And this data is not in the disk, it's in the memory. Okay, and that's what has made it possible to have multiple programs, multiple programming language in a single project. Okay, it's not an event. So the idea is that whenever you are doing your computation, or you are doing building your product, or getting something done, you can write some part of it in R, some part of it in Python, some part of it in SQL, some part of it in anywhere, and the transmission from one language to another doesn't happen through the disk. Okay, so one program comes, it works on something, prepares an array, RDD, and pushes it to the Spark. Now the other program comes in quickly, reads from the RDD, and gets the work done quickly and save it back. So that's what keeps on going back and forth. Okay, so you can also have your own object created which can be pushed onto RDD. All right, that's what happens at the RDT level. Everything clear at this point? Now, this RDD can be persisted into the memory. It can automatically recover from the node failures. It can have any data type but has a special data type for the key value. Okay, it can have any object, but Spark little bit respects the key value pairs because there are lots of functions which are built around key value kind of uh, object. Okay, and this RDD, now you might ask that, okay, fine, we have got an RDD and we somehow loaded the data onto it. Now, what will what all can we do on RDD? RDD has classified functions into two buckets. One is called transformation. So there are some functions which only do transformation, then some functions will only do actions. We'll talk about these two operations in detail. All right. So this is not something required at this point. We'll go through it again. All right. So how do we first create RDD? One is by directly loading data from HDFS. You could simply load data from HDFS very straightforward and easily. And there are hundreds of other sources of data from which the data can be loaded. But we'll go into those details again. All right. Let's try to load the data. So what exactly is happening here? So what is exactly is happening here? We are saying lines is equals to SC. SC is the Spark context. That is your gateway to Spark. All right. So this is your gateway. You can see SC and all the functions that it provides. So SC is your gateway to Spark. And what exactly are we saying? We are saying sc.text file, please load my text file. And when we say hdfs colon, we are telling Spark that we are trying to load data from hdfs. So at this point, so when we mention hdfs here, Spark would understand that we are trying to load data from hdfs, and accordingly it will plan the loading of data. It might load data from HDFS such that various machines are near to the node containing the blocks. Okay, so at this point, Spark will talk to Yarn and try to load data from there. So now it has successfully loaded the data from the text file into lines. Okay, any questions at this point? So we were able to load the data. All right. Or sometimes you don't have to load the data. Sometimes, let me just make it, right? Sometimes you don't have to load the data. You were working on your normal work, like your existing product, and you have some object which you want to load it into Spark. Let's say you have an array. This is my array. See the array? It has got 10,000 element, 10 lakhs element. I don't know when it's going to finish, but it was a mistake. I'm not sure if it will. Oh God. Yeah. So yeah. So let's say we have an object called array here. We can say len array, which has got how many? Around a million objects. Okay. We already have this in memory. maybe because of some other program or something like that, or maybe because we have just created it and we want to push it to Spark. We want to push it to RDD. We could simply say sc.parallelize, and sc.parallelize will return, it will return a RDD. Let's see. So here the way we had, okay. So similarly, we have earlier we said sc.text file. As I told you, sc is our gateway to Spark. So text file basically loads the data from text file using Spark, and lines is kind of a representation of the same. Okay, now you can see what is numbers. Says numbers is a parallel collection RDD, and it's from that. Okay. All right. Again, if you want to see what exactly is what functions does numbers support, you can simply say help numbers. Okay. And since numbers is a RDD, it shows you that it's a RDD containing all these methods: aggregate, cache, Cartesian, co-group, collect, collect as map, and all that. Okay. Are you with me? All right. So a quick question to all of you. If my computer has 8 GB memory, 8 GB memory, or I can say 8 GB RAM and 64 GB disk, and there are 20 such computers in network. How big RDD can we load? Yes. So if I have a computer which has got 8 GB RAM and 64 GB disk, okay, it's not a TB, it's just GB, and there are around 20 such computers in the network. How big data can we load on RDD? Yeah, correct. Approximately 160 GB. Okay. Assuming that the full memory is dedicated to you, then you'll get 160 GB. But it will be something like, maybe if you think about all the computers and leaving 1 GB there, so you can say 140 GB. Okay. Good. Very good. Correct. So that was a quick question just to check if you are with me, or okay. So using parallelize, we converted a local object into an RDD. Now, once we have converted something into RDD, we can apply all the operations we want to on this RDD. So it gives us a great way of connecting to multiple systems and bringing data from there, as well as it also brings us the way to load the data. Now, if you had to load from elsewhere, we will use a different protocol. If we want to load the data from HTTP, we will say HTTP. Or we want to load from elsewhere, we will use that protocol. Okay. Text file signals to our Spark that this file has to be loaded such that the elements in lines are, each element is a line. Okay, so lines is basically a big array of lines where each line is an element in that array. That's how you can look at it. Okay, so if you want to have a quick look into it, you could simply say lines, and then you can say lines take 20. You can see that. Okay, okay. So RDD is lines is an RDD, numbers is an RDD. We have loaded this particular HDFS file. You can see this HDFS file. Okay, we have loaded this HDFS file into an RDD. Okay, and this numbers is also another RDD. It is loaded from our local object has been converted into an RDD. All right. Good. Now on every RDD, so is this clear to everyone what exactly happened here? At this point, when this is Spark context is told that we are trying to load a text file and our URL for the text file is this. And what is this? Under the data mr word count input big.txt. We can have a look at this file, the file which we are dealing with. Okay, what was the password? Okay, so we could go into the file browser and we can simply write something like slash data slash mr slash word count slash input, and there we are. So you can see that Spark, here we have to remove all of this. Yeah, now you can see that it has found the big.txt. Alright, in the same fashion we can keep on loading data from various sources. All you need to do is change the protocol for different mechanisms. All right. Now, loading on RDD is fine. We loaded data on RDD. We loaded data onto resilience distribute dataset from HDFS. And please note that when we are loading data like here, it'll make sure that the data that gets loaded on machine 1 should be closer to machine 1. Data that gets loaded to machine 2 should be very closer to machine 2, and so on. Okay, and this will be done because RDD, I mean the Spark, will communicate with the name node at this point and will find out the block locations of various parts and accordingly allocate the various machines for RDD. All right. All right. So what can we do on RDD? We can do a lot of things on top of RDD. Also note that whatever we do, we never modify an RDD. Instead, we create a fresh RDD on which we store the fresh new data. And how does this new data get created from old data? By the way of multiple functions. All right. So the general classification of functions in the RDD is the transformation and action. Transformation transforms the data, while action gets something done and launches all the things before the action. And whatever is the result, it brings that result back to the local machine. Okay. So the way loaded the data from remote, or converted our local data into RDD. Action converts an RDD into local data. All right. Now, the important part about all of this is transformation does not get executed right away. Transformation get executed only when the action get executed. So transformation, let's go into more details about transformation. So basically RDD, most of the functions are classified either as transformation or action. Understanding transformation is very important. Here you can see that this is where your program is written, Spark driver application. Or Spark driver application, you can say that this interactive command prompt is also Spark driver at this moment. So this Spark driver is telling the RDD to execute transformation. So every transformation function, a transformation is nothing but a function that gets executed on all the element of RDD, and whatever is the result gets saved onto another RDD. Okay. So transformations are operations on RDD. Every transformation returns a fresh new RDD, such as map and filter. Okay, you can see clearly that there is a transformation happening. Also, please note here that this transformation will be very latency free, as in the data will not generally transfer over the network boundaries. It will be the new RDD that is getting created. Its machine 1 will be closer to, would be mostly the same as machine 1. So this section would go into the same machine, this section would go into the same machine as the other one, and so on. So that this transformation does not take much time. Also, please note that same transformation what Spark has executed, this driver which is you right now, whatever you execute, this transformation, whatever transformation you execute, that get executed parallelly on all the nodes. Here there are 4 nodes, 1, 2, 3, 4, and therefore there are 4 transformations happening. So the output of first transformation from here goes to the first section, and so on. These are called partitions. It has got 4 partitions which when passed through transformation generate more partitions. Alright. Ishwar's question is, do we need to map transformations to the node? No. There is something which is taken care of by our Spark. Alright. Is a transformation clear to you? So any questions, Mehndi, Gaurav, Ishwar? Harsha, Jitender, Ashish. All right, let's take example of few transformations. So Mehendi's question is, could you help me to get the JDBC or ODBC driver for Spark to connect with Hive? So the SQL context does that kind of thing. Okay. Okay. I need to have, figure out a time plan for this. Okay. Right now, I'll let you know, Mehdi. Or you could drop me an email so that I can, you know, put you with somebody who can help you with. All right. Sure. We'll discuss it offline. All right. So you can see the transformation example. You see that, let's say we have loaded these many elements, okay? And then, and how, first we created a local object, and then we said nums equals to sc.parallelize, and after that we are saying define this function, and then execute it. So this is where the transformation is happening. The most easiest example of transformation is a map. Okay, and what does map do? Map exactly does what Python map did. It takes your function, it takes your function and apply that function on every element of the array, and then whatever is the result of the transformation, it saves it in another array. Okay, so we have defined a function called multiply by 2, which basically multiplies any number which is, we are passing a single number here, with any single number, it multiplies by 2 and returns that. Okay, so this function takes only one value at a time, multiplies by 2 and returns. Now this map function, we are saying num.map, num.map, and we are providing the function definition. Basically we are passing function as the argument. Okay, what will it do? Nums is an RDD, right? Nums is an RDD. On top of nums, say nums is 1, 2, 3, 4. Okay, so for each element, our function called map by 2 will get executed. Here map by 2 gets 1 as argument, map by 2 gets 2 as argument, here map by 2 gets 3 as argument, and map by 2 gets 4 as argument. That's what happens over RDD, and whatever is the result of execution of these functions gets saved in another array, and which we can utilize at later point. Let's try to execute it. Okay, let's try to execute it. All right, those who are not aware of it, so this means we are saying create an array which has starting with 1 and till here before this. Okay, all right, for simplicity sake we can say things like 100. And if you see, when I say ARR, do you see there are 100 elements? Actually 99 elements. Okay, you can see. So it basically created a big array locally, and then we'll convert this big array which we created locally into 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 an array big, okay, into an RDD. We'll convert this ARR into a big RDD. Okay, let's try to do that. Done. Then we multiply all these numbers by we first define a function called multiply by 2. Okay, what happened to this? Oh, we had to increase the expectation indentation. Please note, if you are working in Python, the indentation is very important. Okay. Okay. So now we have just defined a function called multiply by 2. We can try calling it. Okay. Do you see that? 3 has been multiplied by 2 and 6. 5 has been multiplied by 2 and it's 10. Okay. So any argument you pass to the multiply by 2, it will return you the double of that value. Once that is done, the next thing we do is we say, get me execute map on top of my nums. Let's try to demonstrate that. Okay, so nums was, what was nums? Let's see what was nums. Nums was an RDD. Okay, and what is the DBLS? DBLS. DBLS is also an RDD which is called pipe lined RDD. All right. So map is a transformation here. When we executed map, we executed map on top of an RDD called nums. And when we executed map, the result was stored in DBLS, which is another RDD. Okay. All right. Now at this point of time, you can say take, and it will bring data back from RDD to locally. Here I'm saying take 5. So give me 5 elements from the RDD to locally. And this number, this variable is actually local. We can say x equals to this. And when I say type of x, it says it's a list. It's no longer an RDD. Okay. So take basically brings data from there to local. Just give me a minute. All right. All right. So yeah, we could basically do various kinds of operations here. Is this clear to everyone? This example? Now Asish's question is, let me try to put his question. Okay. We can process array of size m into n where m equals to 2 and n equals to etc, or always we have an array of size 1 into n. I did not get this. So can we process array of size m into n where m equals to 2 and n equals to so it is let me try to understand what do we mean. Yeah. So what you're talking about is right now when we are dealing with RDD, right? It is something like this. Okay. where it is basically an array of single element. Okay, what if you want to have multiple elements together, something like this, right? You could do things of this sort. If you want to keep multiple objects together, you can create array of arrays. You got it now? Is this what you were looking for? No. So you could create an array of arrays, and this will be a single object. And when you say map, this particular thing will get called. Okay? Do you want to try this out now? Ashish, should we try this out? Let's say we are saying for I in range, let's say range 1 to 100, and for j in range 1 to 10. Okay, and let's say our array is empty. Okay, and we say b equals to empty, and we keep on appending first this, and then we can say a dot append b. Okay, what are we doing? We are trying to create an array, a big array of 100 elements, where each element is an array of 10 elements. Is that what you wanted? So let's try to create that. Very good question. Sorry, we have to put colon here, colon here. All right. So you can see that A is like this. You see. And let's say we want to compute the summation of all of this. Okay, so we define our map, okay, which takes some values and returns sum. Okay, so if we pass map 1 to 3 or 1 to 3, it'll give us a summation of, oh sorry, so we could say um we had to create sum of an array, return sum of x. Okay, that's all. Now if we say sum underscore array 1 comma 2, it'll give us 3. All right, now let's try to execute. So we have created an array. Is that an array? Yeah, so we are saying capital A equals to sc dot parallelize, and we are saying small a. So we are converting our array of arrays into an RDD. Okay, we converted this into an RDD. Now we can say run my function called sm dot arr. Okay, and we could save the output into b, and we can say b dot take say first 10 elements. You can see it has summed up individual values 45, 45, 45. Sounds good? All right. So this element, what we just demonstrated, that element can be a complex object. It can itself be an array, or it can itself be some other object, or a combination of object. It could be array of arrays. Whatever you want to keep here, is you can keep here. Just keep in mind that since individual object individual object resides in the local memory and is indivisible, it cannot be divided into multiple computers. Therefore, such an object will overflow the memory if it grows bigger. Okay? Because this is not, individual object is not divisible. Only this array is divided. So when you are when you are building your construct or data structures, make sure that individual object does not grow so big that it overflows the memory of a single node. Okay, that is a very important part. And in case you the other downside of such a big object is that the processing of such a big object will not be distributed across the cluster. It will keep only a single node busy. So the whole purpose of having distributed computing will go useless. Okay? Will not be of any use if you try to create the very big object. Sounds sensible to you? Do you guys want to try this out? Try this example by yourself? I can wait, and we can have this next 10 minutes just for our hands-on. Are you trying? Gaurav, Ashish, Harsha, Mehndi, Ishwar. Can you try this example? In case you get stuck, we'll just share your screen and we'll resolve your issues. Okay, Harsha, try. Did it work, Harsha? If it did not work, I'll make you the presenter and we'll resolve the issue. Okay? Great. For Harsha, it has worked. Okay? For Mehdi also, it works. Good. I'm really happy. That is the benefit of doing it in Python, that everything gets done quickly. And it's very important to get it done. Otherwise, you will, after this class, you will completely forget about it. And then you'll not get time. So, Gaurav and Ashish and Jitender, are you trying? Ishwar? Okay. All right. Jitender, basically we are trying to execute these commands. We first created a big array. We loaded that big array onto Spark using sc.parallelize. And after that, we created a function called multiply by 2, okay, which basically whatever number you pass to this function, we multiply it by 2. Now we send this function to our RDD for the execution. Okay, that's what we are trying to do by the way of this. Okay, and whatever is the result of running multiply by 2 on every element, we store it here and then we take 5 element out of it. Awesome, Gaurav's worked. Okay. So Jitender, is it clear? So the idea is to get it executed right away using Spark. All right. Now Harsha's question is, so Jitender, are you still lost? All right. Only Ashish and Iswar are left, and Jitender. Oh, okay. Oh, you lost the connection. I thought you. Okay. All right. Okay. Try. It's not. It'll be done very quickly. All right. Okay. In case you get stuck, I will. All right. Presentation. Is it available here? Is it available? Is it opening for you? This one. Okay. All right. All right. So I was just doing this and then this and then this. Okay. So we defined it. Then good. Let me just send you this piece of code. All right. I sent you the code. And also the presentation is, I think, available to you, everyone. All right. So did you get my code? I sent to all of you. All right. Let me answer Harsha's question. All right. Okay. So I've shared the code and I've shared all of you the slides also, although it's available in the server. Now there is a question from Harsha. Uh, the question is, if my dataset is huge, can Spark RDD handle such datasets? Of course. Okay, that's what it is meant for. For rest of the things, there are other systems. Okay, so it is meant for huge datasets only. Because this RDD, the main reason why most of the systems are not able to load um, Big data, big data is mainly because of one is IO speed, other is the memory availability. All right. All right, Iswar, are you able to do it? Jitender? All you need to do is run PySpark and then run these commands. Okay. All right. So this was a very quick and simple example of doing the transformation. In this transformation, what has happened is it transformation of one RDD called nums has resulted in another RDD called DBLS. And to get the data from DBLS, we have used take. All right, and that's what is happening. Good. Ishwar is able to do. Anybody else? Ashish? All right. Now this is an example of tuple. We will consider this later. This has to be moved. That's what it says, to be moved. Okay. Now the second part of the RDD is action. Okay. So Ashish, do you need any help? I can wait. No issues. Okay. If you want, I can take I can make you the presenter, and whatever is wherever you're stuck, we can have a look at it quickly. Expected as indented block. So make sure that whatever we are doing here, all right, let me just show you what exactly is wrong with your code. Yeah, so make sure that there is no space before any of this, and make sure there is exactly one tab space here. Execute one statement at a time. Okay, execute one statement at a time. Okay, I think let's just get it done within. Okay. All right. So those who have already done it, let me ask them a question. Okay. If you were to plot a graph of equation y is equals to 2 into x plus 3. Okay. If you had to plot the graph of the equation, what will you do? So you will generate, okay, generate x from say 1 to 1000, and you will generate for each x. Okay, so create two RDDs x and y for the same. Yeah. So x is containing an array from 1 to 1000 and y is containing the value of y according to this equation. An array of values for each x. Can you do it for rest of the people while Ashish and Jitender is finishing the previous one? Let's do that way. Okay, so everybody, the question is clear? For this equation, this is our equation. Okay. Let me just help Ashish a bit and then yeah. All right. Okay, Ashish, I have made you the presenter. Maybe. All right. Keep doing. Yeah. So what does it say? No, in the range you have to put round bracket, not square brackets. Yeah. Good. You can just copy paste it. Yeah. You can just copy paste. It's one statement at a time. It's not letting you paste. Oh, it's not letting you paste. Okay. All right. You can type it. You can type it. Yeah. Nums equals to sc dot parallelize pa array r a double l e l I z e bracket arr. Yep. All right. Okay. You do that. Yeah. And let you do that. By the time, let me have Jitender. You want me to have a look at your screen if you're stuck? Okay. Let me take back the. All right. Just take 2 minutes. I made you the presenter. Let me mute you. You can type it whenever you want. Okay, so that function is not defined. So press up arrow key, enter, tab, Press tab. Yeah. Type return x into 2. No bracket, no bracket, no bracket. Enter. Again enter. Yep. Now try running your function multiple by 2. Try running that function. Just like that. Just type multiple by 2 and then put some value. Enter. Good, good. So it's working now. I think rest of it is very straightforward. You can do that. All right, great. All right then, for everyone, yeah. So that's pretty much for today. You can, yeah. Ashish and Jitender, if you want, I can, we can finish it and then, yeah, leave. All right. For everyone else, you can take a break now. Good, good. So for Jitender, it has worked. Great. And for Ashish, is it working? Great. So everybody is able to get it done. Ashish, need any help? All right. For everyone else, you can take a break now. Thank you very much. So, yeah, let me make Ashish the presenter. All right. So for you, you're Ashish, right? Yeah. For you, again, the mistake you're making is after return x into 2, you have to press enter twice. So don't type the next command until you see the prompt again. Define the function. Define the function. Not this one, the previous line. Def multiply by 2. Yeah, enter. Tab. No, enter. Tab. Return. Yeah, enter. Again enter. No, no, no. You have to you delete everything and press enter. You are still in function definition. Enter. Hmm. Now the function is finished. Now we can test the function quickly. No, you can just simply say, simply try to run this function multiply by 2. No, no, not like this, not like this. So, yeah, you're trying to, because you're trying to create map equals to array, right? Instead of that, you can say nums.map, okay, and then multiply by 2 in the bracket, round bracket. Without asterisk. No, no, no. Okay, remove the whole line. I'll tell you. Say dbls equals. All right. Enter. Good. It has worked. Good. It has worked. Great. Can we? But can we? That browser, I don't know how does it work for Windows. It doesn't seem to make the copy paste work. Okay. Yeah. That's a big problem actually. I think most of you are facing that problem. Uh, okay. Just a second. Let me check. You are Jitender Ashish, right? Okay. Yeah, go ahead. There's
Hi
a lot.
Sandeep, good morning.
Good morning. Yeah, there's a lot of sound. Yeah. Go ahead.
Yeah, actually, last week I tried installing Spark on Windows. Okay,
Okay.
so everything went fine, but by default it is opening only Scala cell. Okay,
Okay.
I I installed Python as well, it's Python interpreter separately,
Okay.
but I'm not able to get the Python cell there on Windows.
Show me where you did install.
Unfortunately, it is on my other laptop, and
Okay,
that's why
okay,
I'm
okay,
not able to.
okay. If you
So,
try double clicking PySpark, it should work.
is it is something saying some class path is something class error because I'm not from Java background, so I'm not able to tell you exactly.
Okay,
But
okay. What you can do is you can go to the command prompt. Okay, you can
mm-hmm,
go to the command prompt and also
mm-hmm,
make sure that in the path you should mention the
mm-hmm,
place where you have
mm-hmm,
install the Python. Okay, once you have
mm-hmm.
mentioned, so okay, also while installing Python, make sure that you install the lower version of Python, something like 2.6 or 2.7. Okay, install
Okay, okay.
2.7.
I went for 3.2 something.
That would be a problem. That would be a problem. Okay.
Okay. Okay. So I'll try with that today.
All right. Great.
Um,
All right then.
okay.
Yep.
Okay. Thanks.
Yeah.
Thanks, Sandeep. Mm.
All right, Ashish. Okay, everyone, and thank you for the support. And yeah, I hope it helps to as well. Okay. All right then. Did I leave anybody's question unanswered? Yes, in DBLS, take and parallelize are the functions provided by RDD. Okay, because we are saying dbls dot take, or we are saying sc dot parallelize, they are provided by Spark. All right. All right. Is anybody trying the second question which I gave you? This one. Okay. Ishwar is saying that. Uh, okay. So yeah, your answer seems to be correct. Okay. So 2 into 2 into is 4, into 2 is 8. 8 plus 2 is 10, 13. Yeah, your answer seems to be correct. Great, Ishwar. Yeah, thank you. And let me just answer. Okay. So y would come out to be something like this. Great. The answer seems to be correct. So Ashish's question is, is DBLS an action function? No. DBLS is nums is an RDD. So SC is the entry point, the Spark context which is provided to you. Num is a RDD. Same is DBLS is an RDD. Nums is when you run map on nums, it's giving another RDD. Okay. Take is an action. We will talk about action later. And these are all Java. These are all normal Python functions. This is a normal Python function. This is a normal Python function, and that's all. Sure, sure. So Ishwar's question is, can we get more exercises? Yes, we will do that. Okay, we'll put more exercises. All right, great. All right. So, okay. Does anybody need help with respect to the second question, or you want to take a break now? Or we can do one thing, that once you finish it, just drop me an email at support at no big data, and that will be good. All right. All right. If you get stuck, just let me know. Great. All right. Thank you very much. Have a great day. Bye bye. All right, Ishwar. All right, Mehdi. All right, Jitender. All right, Ashish. Bye bye. Have a good day.